In this section of the tutorial, we're going to talk about how to generate the streamlines. Uh, that will also be generated with the major inputs being the digital elevation model. So even though the stream is a vector, the bottom line really is that you are still generating the streamline from a raster. So it's a raster operation. So you click on raster, go down to hydrologic modeling. You can see that there are many operations here. I just worked on a terrain analysis. This is hydrologic. You have groundwater modeling, landscape patch, wildfire modeling. That's why I said GIS is really rich in terms of raster analysis. That's why I use it for raster analysis to a large extent, especially terrain analysis, and of course, QGIS for map representations. Now, hydrologic modeling, you go down, you can see, you can draw some watershed maps, sub basins, and lots of other uh, map products using this hydrologic modeling. But of course, I'm looking to generate streams, extraction of stream networks. So r.stream.extract. So you are looking to extract stream networks from your data elevation model. So click on that. Now, the first option here, you have required input maps, output maps, then of course the optional tools, and of course finally the command and then manual. So what is required? Said name of inputs elevation map. What is the name of input elevation map? This elevation model. Click on this and select Anambra BB DEM. Now, minimum flow accumulation for streams. Usually, flow accumulation talks about how much, if it's in a terrain now, it's, let's say you're talking about, let's say, let me make it more like if it rains, for instance, out there, when it rains, you discover that water flows generally flat on the surface, but then eventually you see that it accumulates within channels. That's those channels are basically, it's all about how much water accumulates within each grid cell. You will discover that along that stream channel, that channel where the water accumulates, those channels will have, those grids that fall within those channels will have higher flow accumulation than the grids that fall within areas which are basically uplands that don't really have a lot of water flowing on them. That is basically what the flow accumulation really entails. Now, this talks about minimum accumulation for streams. What is the minimum value of flow for that would give you, that you use to define what is a stream? Let's say, for instance, you take 5,000, for instance. 5,000 will generate some streamlines for you if that's the minimum. If you take 15,000 as a minimum, you have less of the streamlines generated. If you take 20,000, you have even less streamlines generated. If you take 500, you have a lot of lines generated because depending on what you collect, you take as your minimum flow accumulation. Uh, the higher the value, it means if I were to take, let's say, for instance, 10,000, I might end up generating only rivers in terms of the final output of stream networks that I generate. Whereas if I select 500 or even 250 or 100, then even those channels through which what rain flows when it rains torrentially on the streets, these are not permanent, these are just basically channels. It might still generate those channels as streamlines. So the higher the threshold value I select, the more likely I'm going to get a real perennial stream or at least a seasonal stream, and not just a flow channel where water flows when it rains torrentially, especially within the tropics where you have lots of torrential rain. So the humid tropics, I mean. So that's basically what you define here. We'll try and see, we'll try several options. Let's use 5,000. Anambra is a large, if it were a small area, I would say let's use a smaller value and then see how it's. So I don't want to have a lot of the streams showing up. So let's say 5,000 for instance. Use 5,000 as the minimum flow accumulation. You go to inputs, said name of input accumulation raster map. You can generate the flow accumulation. Actually, there's a way to generate flow accumulation. I don't want to go into that process. Of course, if I had generated the flow accumulation, I would have selected it from here. Then, of course, name of input raster map with real depressions. I will not generate that either. But like I said, as we saw with the geomorphons, it will generate it on its own in order to be able to calculate to generate the streamlines, but it will not represent it as an image or as a product because I'm not defining it. And of course, I can't even define it here because I need to generate it with another tool and then use it here. But I didn't generate it, so it will generate it underneath and then use it to run its own analysis and generate the streamlines that I need. Now define the output. You can define three sets of output here. Name of output raster map with unique stream IDs. This is a raster map that defines the streams. I don't need a raster map, I need a vector map of the streams. So I might decide to ignore that. Say name of output vector map with unique stream IDs. Well, I might call that Anambra BB streams. Well, given the fact that I'm using 5,000, I might try others. Let's say streams 5,000. Then name of output raster map with flow direction. I don't need that for now, so I just need the streams. So having defined that, I run. It shouldn't take that long either because it's just a vector I'm trying to generate. But you never can tell. It's running. At the very least, I don't expect it to take as long as it did with the generation of the geomorphic units. Definitely not that long. So it's apparently running the analysis in iterations. And I think it's done. So finally, it is done. So well, let's look at what we generated. We can do others. You can see the lines. Those lines are the lines that the streamlines basically. You can activate and deactivate it, but these are basically the streamlines. Uh, let's do something else. Let's increase to 10,000 and see what it looks like. And of course, let's also then decrease to 2,500 and then see what it looks like. But I think this is adequate for my own needs at the moment. But let's see what 10,000 and 2,500 looks like. So go back, change this to 10,000, then input nothing, change the name. Let's still make this 10,000, run. So when we're done running this, we will now talk about how to export this data into a format that any other software, including QGIS, can read. The way this GraphGIS works, all these operations are saved in a format that no other software or GIS application can actually use. So you need to resave them with the common raster formats so that once you want to open it in QGIS or ArcGIS or any other GIS application, you can easily open it and then run your operations there. So when we are done with this computation, then we will now talk about how to export both the raster and the vector data into a format that is usable in other applications. Now, having rounded this off, let's now reduce to 2005 and still run again. And then we'll be done with uh, with Grass GIS for the moment. 2500. Now, 2500 haven't been imputed. Go to impute nothing output. Change the 10,000 to paste that there and then run again. So this is the final run. Eventually we'll export all three streamlines and then along with the relevant raster data, and then of course we'll now open everything again in QGIS and then continue from there. So now it's done. If you look at the layer panel, you see that I now have a three. Now you can close this. I now have three vector layers and of course a couple of raster layers. Now, having done this, I think I'll end this tutorial, this section for now. And then in the next section, I will now talk about how to export your raster and vector data into a format that any other application can visualize and utilize. Thank you.